Hello, my name is Jacob Soloner, and today we're covering problem 3 of the 2014 AP Calculus test. It's a no calculator, but that's not going to be a problem at all. And so let's jump right into it. So the first problem states that this function on this closed interval consists of 3 line segments shown in the figure below. So g is this function, the antiderivative of this function between -3 and some point. So we're going to start by finding g of 3. So the antiderivative, we're really finding this area under the curve between -3 and 3. So 3, what this is 3 triangles. And so we know the area of a triangle. We're going to just do this on our scratch work right here, so we don't write on it. So for 3, part A, the area of a triangle, just making sure you can see that, is 1/2 base times height. So this first triangle with a base of 3 and a height of 4 has an area of 6, plus the area of this triangle with a base of 2, height of 4 is 4, and then this one right here, this triangle has a base of 1 and a height of -2, so that's going to have an area of -1, almost drew negative h there. Be careful not to add this to your area. We're subtracting it. Not going to be too common of a mistake, but just be aware of, this area is not positive. And so this is going to equal 9. The question doesn't ask for units, and the key doesn't give units. So in this walkthrough right here, we're also not going to include units. So part B asks on what open intervals on this graph is the graph of g both increasing and concave down. Give a reason for your answer. So g is this area, so it's going to increase when this. So actually, for this to be concave down and for this to be increasing, this has to be positive and decreasing, because it needs to be the graph itself. G itself has to be concave down, so it has to be increasing at a decreasing rate. And g prime is going to equal f, because it's the antiderivative of, or the derivative of an antiderivative, excuse me. And so the values, so this is, to learn this, it's really an understanding of the relationship between g, g prime, and f of x. So this is chapter 5 and 6 stuff, I think. And so it's going to be in between. Let's just write this down. Yep, you can see that. It's going to be between -5 and -3, because it's decreasing, but it's still, this f value is above 0, and between 0 and 2, because g prime is equal to, I'm just going to scoot that up, f, and is positive and decreasing on those intervals. I guess it's these intervals. Although, hey, this ain't English. So for part C, the function h is defined by h of x equals g of x over 5x. Find h prime of 3. Straighten out the paper. So to do that, just going to do a little bit of quotient rule. So a quick reminder, I think from chapter 3 from lesson 3.3 or 3.4, somewhere around there. The format for a quotient rule is g of so for any function f of x over g of x functions, to take the derivative of this is g of x times f prime of x minus f of x times g prime of x all over g prime of x squared. So not too difficult. We're just plugging in we're going to keep it in terms of g of x and 5x at first. Don't need to throw any numbers in there. And what we're going to get is 5x g prime of x minus g of x times 5 all over 5x squared. And what this is going to simplify into when you replace x with 3 is, so just going to draw an arrow here for the grader to understand our work, is 15 times g prime of 3 minus 5 times g of 3. Make sure you know that this is a function, not a variable. Be aware of that in your work, because sometimes that can get lost. G is not a number. It's g of a number. Excuse me, I'm a bit sick. And so this 5x squared is going to be turned into 25 times 9. Okay, which is going to equal, scoot this paper up just a bit, 225. So now we need to find g prime of 3. So g prime of 3 is going to be on this graph. At this value, 1, 2, 3 is negative 2. So g prime of 3 is negative 2, and then g of 3 we've already solved for is 9. So negative 30, which is this 15 times the negative 2. And then we're subtracting 5 times 9, because 5 in g of 3 is 9. 5 times 9 is going to equal negative 75 over 225. Or if you know your multiples of 25 is negative 1/3. Now for part D, the function p is defined by p of x, blah blah blah. Okay, so what the question's asking you, so whenever you see slope of the tangent line, you gotta think derivative. And so it's really asking for the derivative of this function p of x. So this is chain rule, unit 3.4. So we're just writing down. So we're trying to find p prime of x. So p of x equals f of x squared minus x. And the format of a chain rule is f of g of x equals f prime of g of x times g prime of x. Do I have the right amount of parentheses? Yep. Okay. So pretty simple. F is going to be your f, and x squared minus x is going to be your g. It's going to be f prime of x squared minus x times 2x minus 1, which is the derivative of this 1, and so it's going to be f prime of 2 times negative 3, because the problem is asking for it at the point where x equals negative 1. So that's our x value. So f prime of 2 times negative 3. So I'm not really going to illustrate the work of plugging negative 1 into these pretty simple math, which is happening right now. And so this is going to equal 6. And so the answer, the slope of this line is 6. So f prime of 2 times negative 3 is 6. Okay, so to get f prime of 2, we're going to look at the graph. The slope at 2 is this negative 2. So although this negative 2 right here. So it looks like we just kind of ignored this f prime, but of course you got to remember this is a negative. This f prime of 2 is actually a negative number. We're just going to show this step. Negative 2 times negative 3 equals 6. And that's that slope of your tangent line. I hope you learned something, and thank you for watching.